This video is accompanies CIS 307 as part of the Iowa Community College Online Consortium, Chapter 7, Database Management System Functions. The textbook begins, or the chapter begins, by identifying 9 critical functions that are essential for a good database management program. One would be the ability to update and retrieve data, to provide catalog services, to support concurrent updates, to recover data, to provide security services, to provide data integrity features, to support data independence, to support data replication, and to provide utility services. After it introduces the data on the first page of the chapter, it then goes in and discusses each of these 9 features. So the first one we're going to talk about is the update and retrieval. This one's pretty basic. Many of these features, by the way, we've discussed in earlier chapters. You just didn't realize it was one of the features that was required at a DBMS. The ability to update and retrieve data includes you have to be able to, in a DBMS program, add records. You need to be able to update records, or in other words, make changes or edits to the existing records. You need to be able to delete records, and you need to be able to retrieve the data that has been stored in the tables. Now, at first glance, this might seem like pretty basic stuff, but when you think about it, for example, something like changing a record, well, what really has to happen is first I have to ask to see the record. So I have to have a way to be able to get and narrow it down to seeing the record that I want to change. And after I've requested that data and it's pulled that data and is showing me that record, now I have to edit that record, or my user has to edit that record, make the changes, and then somehow commit those changes. So it's, as I'm editing those changes or making those changes, I somehow then commit them back to the tables. So there's a lot more steps involved in something as simple as editing records than people may realize at first glance. But overall, this is a pretty basic concept and should be pretty easy for you to understand. The next one that it talks about is catalog services. And catalog services can include a variety of things. It's basically data about the data, and it's referred to as metadata. And so it includes things such as the descriptions of the table, the definitions of the fields, the relationships, how the tables are related to each other, what views we've established, what indexes we've established, and there's a few other items. So basically, in a good database, especially in a big enterprise database system, it's going to be a set of tables about the tables is what the catalog is. So the catalog actually is where the information about all of the table designs is stored. The metadata is definitely hidden from the end user. Only the programmer, the database administrator, those people actually have the ability to see the metadata. Often when you're working in the back end of the database and you actually are able to see the metadata in programs like Oracle, it's referred to as a data dictionary. In something more like an Access program or a PC-based database management system, you're not going to have a data dictionary. There is a catalog that you can get to, but it's not as front and center. It's not as easy to get to it and find it. The next one they talk about is the ability to support concurrent update. And what concurrent update is say you have multiple users who are changing the same tables simultaneously. There can be problems when 2 users are trying to edit the same record because those users can make conflicting changes. Okay, so imagine for a minute that you've got 2 different people who take phone calls from customers calling in to make simple address and telephone changes. So John Doe, the customer, calls and Susie answers the phone and he says, I've got a new address. So she brings up the screen for address change and she changes the address. And she says, "Hey, do you have a new phone number?" And he says, "Oh, well, I'll get a new phone number later today." "Okay, we'll call back when you have the new phone number." So the new address is still sitting on her screen with the old phone number, and Susie gets called away, and as a result, she never commits or saves that data to the database. So you've got on her screen the new address, the old telephone number. Meanwhile, an hour later, John Doe calls in, and Mary takes the call, and he says, "I called with my new address earlier today, but they told me to call back with my phone number." Well, Mary's also a very busy person, so she brings up John Doe's record, and what she's going to see is his old address and his old phone number, but she doesn't verify the address. She's been told to change the phone number, so she gets to his record, puts the new phone number in, and she does save or commit the data to the database. So now in the database stored is the old address and the new telephone. Meanwhile, Susie comes back to her desk. On her screen is the new address, old telephone, and she goes, "Oh, I never saved this. Save." So as a result, the Susie's data overrides Mary's data. And so this can create a problem. So there's so different ways to handle this problem. One method is to take a look at something called batch processing. Now, what batch processes are is the updates would actually be stored throughout a period of time into one file, and then at some point during the day the batch would be run, and that way when you have those types of conflicting information, you should see it within the batch records. You should see that there have been multiple edits to the same customer file, and of course then programmatically you would, before applying the batch, you would look at the batch and you would look for those records that were to the same customer and rectify those conflicts before actually updating the database. That's definitely a solution you'll see applied at times through enterprise database solutions. Another solution that is both in the larger enterprise systems as well as you'll see on the PC-based systems is record locking. What record locking would have done, and I think this is a much more common solution, is when John Doe called back the second time, since his record was already on Susie's screen, Mary would not have been able to bring up the record. Now, she may have received a message that said it was locked. She may have received a message that said it was locked by Susie and specifically told her who had the data locked, so that she could contact Susie and try to figure out why Susie was in the record. But point is it would not have allowed the second user to get to the data because somebody else already had that record on her screen. I think overall that's probably the more common solution that you're going to see throughout your use. You're working with databases. The textbook spends quite a bit of time on pages 240 to 242 discussing even further problems that can result from the concurrent update issues. It discusses deadlocks. What a deadlock is when you have two individuals they were kind of waiting on each other for the same data. For example, let's say you had two different sales reps and they each bring up a customer, but now one of them, each customer orders a washer and a dryer. So the first sales rep goes into the washer inventory and says, "Yeah, we have one in stock," and now he has that open. The second sales rep happens to do the dryer first, so she's got the dryer inventory locked. This is the washer dryer example they use in the book. So now each user is waiting for the other one. Like the first sales rep already has accessed the washers, but now can't access the dryers because the other sales rep has accessed the dryers but doesn't have the ability to access the washers, and so they're both kind of waiting on each other. They're waiting for that other piece to unlock. So that's it can be a problem that you have to be able to resolve that problem. Um, there's talks about on 241 a lot of various issues that could come up with locking on PC based databases. And I think one of the big differences, at least with my experience, is that when you're at the PC based database, I'm going to use record locking, but it can be more complex if I have, say, a form with a subform, thus I'm accessing multiple tables, or user interface that's based off of views rather than tables. The view might actually have data from a couple of different tables. So as a result, I may be locking multiple records in multiple tables, or even sometimes having to lock entire tables. So um, this can be a little more time consuming sometimes on the programmer's standpoint. And then timestamps are discussed at the end of this section. And the solution, timestamps being another solution, basically every um, update gets a timestamp attached to it, and it processes those updates according to the timestamp. So if two users had the ability to access the data and see the data at the same time, but one person's timestamp would beat out another person's timestamp. Now, this would work for something like the washer dryer example, where each sales rep was just trying to access the inventory and order one. If there was, for example, only one washer left, basically it would be whoever managed to hit the order, the final save button first is the person who would get that washer. But timestamps aren't going to work as well on something like my example of the person calling in twice and it being on one person's screen with the new address, old phone, somebody else's screen with the old address, new phone. That really just overall record locking is the only type of solution to make sure that scenario doesn't happen. So you're very likely going to apply different solutions to the concurrent update problem. The solution you don't want to do is go to a single user database where you might as well be in Excel then, where only one person can access the database at a time. But you do have to understand that we cannot have everybody accessing everything at any given moment. So you have to somehow programmatically handle the concurrent updates, and there are features built into the DBMS to assist you in handling these scenarios. A DBMS has to have a way to recover data. In other words, some type of process of returning the database to its correct state after there's been any type of damage to the database. And there are a variety of ways to handle this as well. Usually in an enterprise or a larger database system, you're going to see some type of journaling where it actually maintains a log of all of the updates. And it's probably going to keep a before image and an after image. In other words, a picture of what the data looked like before the update, a picture of what the data looked like after the update. It's going to keep a log that tells me the start. In other words, at what point did the user begin the update? What point did the user finish or save the update? It's probably going to have a variety of actions in the log. For example, start, commit, insert, update, delete. They're just some of the examples. On page 243 they give you an example of a log. Now what's you need to understand with that particular example of the log, if you decide to look through that 4 transaction example there, in order to make it clearer for you to see the timestamp, they did each transaction at 1 minute. So the entire thing takes 17 minutes there. Okay, that this may be something that takes more like 17 seconds, or that might be a little too short, but they made each one a separate minute. Reality is that log is going to take it out, not even necessarily to the second. It might even take it out to the what is it, a nanosecond after, a tenth of a second, whatever it is. And, but it's going to take it out to that point. They just made it a 1 minute in that particular picture to help you understand that time is going by. Another solution that you would have more likely on a PC-based database, something like Access, doesn't do any type of journaling. So then it's up to you, the database administrator, to actually put in a routine set of a procedure of we're going to do backups every day at this time. Maybe we're going to do them every day in the evening. Maybe we want them done more often, so we're going to do them at noon, over their lunch, something. Remember that when you're doing those backups, the database is likely not able to be accessed during that time. So you have to really decide what you um, want, how often you want that to happen. Um, Going back to the journaling for a moment, I did forget to mention forward or backward recovery, and they give you some good pictures on pages 244 and 245 to discuss the differences between forward and backward recovery. Basically, forward recovery is, let's say that we know that the data for the last 10 minutes has been destroyed. So what we can go back 10 minutes and we could through that journal reprocess everything from that back point forward. Okay, so all of those transactions would be processed again in order to get the database back to the state it was in at the time that it was damaged. Um, a backup recovery is the opposite. So we would basically, maybe we have something that is transaction related, so it's kind of like an undo. We're going to roll it back to a certain point, or to the point that we know, well, we know it was valid here, so let's roll it back there, and these transactions are gone. They'll have to be redone because something in there was done erroneously, and that's what led to the problem. So backup is from the start where you're at now, rolling backwards. Forward recovery would be taking it to some point in the past and then reapplying things forward. And of course, those journaling things again are in those enterprise solutions, those larger databases, where the PC based solution for something like Access would be just that the database administrator has to establish a routine schedule of creating backups. The fifth item that they discuss in the chapter is the security services. And they really mention 5 different security services that a DBMS should have. The first one being encryption. And encryption is nothing more than making sure that the data is stored in such a way that it cannot be read by a simple word processor or an Excel program. And of course, if that data is being stored in that encrypted format, then the database has to have the ability to decrypt the data as well. And authentication. This is basically a way somehow that each user of the database is being identified through a username and a password as they log into the database. This is restricting who has access to the database, because each person who attempts to access the data or get to the data must provide some type of password and login. You can take that a step farther. Authentication feeds right into authorizations. With even something as simple as an access, I can actually have each user have a different login, and then I can restrict what each user has access to. I may have some users who have full open access to all tables, and they can edit, change, delete, do everything they want within that database. This is often referred to as wide open access, but I may have other users who can read only, or I can restrict it to certain forms or certain views or certain tables, so that not every user can see everything, or maybe one user can update this side of the database, but they can only view another side of the database, and maybe there's a third piece that they're not even allowed to see or view or anything. So it's kind of, these two kind of work together. The authentication is who the users are, and the authorizations is what each of those users has the ability to do. As discussed earlier, views can be used as security, because they limit what each individual user, based on their user ID, authentication, etc., but they limit what they can see to the field level. Remember that I cannot restrict a user to only certain fields in a table. If they can see the table, they can see the whole table. However, I could pull certain fields out of tables and create a view, and then I could limit the user so they could only see that particular view. Another advantage or reason that view comes over here in security is that I can by creating views, I can then have different rights to the view so that the user maybe can see the data in the view, or excuse me, maybe can do some updates to the view, but I'm not actually allowing them to get back into the table. So it's kind of a couple of different angles that comes from. And of course, privacy. And I think we've discussed earlier that privacy issues are built in. There's something that we respect as companies. Sometimes we work in certain areas like healthcare, education, and things where there actually are federal laws and regulations as to what can or cannot be viewed. So depends on where you're working and as to how much privacy issues are, but usually it falls on the responsibility of the database administrator that to not only restrict the access here, but they're usually within a company in charge of, or at least part of a team that is in charge of making sure that all employees are trained on what privacy issues come into play. So it's just, you can't really talk about security without talking about privacy and the role that plays within the overall security of the database. The sixth function that they talk about are data integrity functions, and these have been discussed earlier, so I'm not going to spend a lot more time on them now, but a good DBMS has the ability to check its data through the data type. For example, if I have a text field, I can have a text field and only put numbers in it, but by making it numeric, is that restricting the user to putting even less into the database? So I'm restricting the possibility of errors. There's always a chance a person can make typos, but I want to restrict that as much as I can, and one way I can do that is through the data type. If it's a date field, I'm going to choose date rather than text, because text means while I may want them to type in a valid date, they could type in an invalid date, where with a date field they are restricted to valid dates only. Another thing I can do is different types of legal values. So you could put in validation rules that say things like, well, this can only be, Iowa or Illinois, or this, what you should put in this field can only be connected to another table through the relationships. So that would be another data integrity, referential integrity. We've talked about that earlier. Legal values, though, really can get into, like that credit limit must be below $15,000. That's the highest one we allow anywhere. So by putting that restriction on it, it takes away the possibility that a user's finger will slip and they'll actually type in 18,000. So obviously by making it a number type of, or a data type of number, I'm only restricting them to those 10 characters, but 0 through 9. But now by also putting a validation rule on it that says less than 15,000, this is restricting it even more. The author mentions format as one, and while to me that is a display format, and I think if users are used to seeing it a certain way, it helps them understand what they should put in, but I personally don't quite see that as a data integrity feature, but we'll go with it. Then they talk about the 4 different levels or different ways that these constraints can be handled. And I find it interesting that for the first one, they just go, well, you can ignore them. And then they act like that's a viable solution. But I suppose ignoring them is just like not putting them in at all. To me, it's more important that you focus on the second, third, and fourth integrity constraints. This is on page 248, which would be user-controlled programmer controlled and DBMS controlled. And you do actually have to have a variety of all three of these types of constraints. Um, there are times where the only real good constraint you could come up with is to train the users and to tell them this is the only acceptable data. Maybe that's because your database is part of a bigger database. For example, I think I've mentioned this one before, but here at the college we use a database system for our registration and student data that is used by many, many institutions across the world, and it has the ability to have multiple majors. We, however, have users trained so that each student only has one primary and then multiple secondary majors. Even though the software, the database itself allows multiple primary majors, it's through user training that we restrict that. But then we do also have to create a series of audit reports to look for those types of screw ups, the times that somebody's accidentally given a student two primary majors. Where something that would be programmer controlled might be something more like if I had a field for race and I've restricted it to, 6 different race types, and am I going to make them choose one? Or am I going to allow them to make it a multi-valued field where you could actually choose more than one race? And then finally, the highest or the strongest integrity constraint would be those that are DBMS. So that it doesn't, when the database doesn't even allow the data to be added itself, because the constraint was placed within the database system. So you really want a combination of all of these. Well, not necessarily the ignored, but of the other three. Even if it is DBMS controlled, you still need to train the users, because there's nothing more frustrating to a user than they think they've done it right and they have typed it in and they are hitting save and they get nothing but error, 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 and they have no idea why. So you still have to have user training. You still have certain aspects of it that are controlled by the programmer and certain aspects that are controlled by the DBMS itself. But integrity constraints can be extremely important, and in order to assist us in getting clean data in our database, I'd rather have no data than have bad data. The seventh one they discuss is data independence, and it's just basically saying that the data is independent from the user interface. So I can modify the user interface. I can change, the screen colors or the fonts or the order that data is actually input, and it doesn't affect the back end or the table design. Yet I also can go back into the table design and I can add fields to the tables, change the field length, create indexes, change relationships, and do all of that stuff on the back end, and it does not affect the front end. Now there's going to be times where I need to both affect the front and the back end. For example, let's say we only stored the customer's first and last name, and now we, for whatever reason, need the customer's middle initial. That would involve me having to go to the back end, to the actual table design itself, and add the field. That's easy enough to do, but there's no way for them to put any data into that field if I don't go to the front end and also add a box tying to that field in the back end. So yeah, there's times where I'm going to have to change both, but I may do something like change the field length back in the back end, and it has no effect to the user interface, or go to the user interface and change the way data is input in, and it would have no effect on the back end. So it's very important that you have data independence, that your tables and your interface or forms are separated from each other. Same with reports, that they're separate. Eighth function that they discuss is data replication. This is the managing multiple copies of the same data. These multiple copies are called replicas. You're often going to use this in situations where you have your different locations that need to access the database are maybe at different parts of the country, and so it can be very slow to access one central database system. So instead we're going to make replicas of the database, so each site has a local copy of the database, and then there'd be various times during the day where that database would be exchanged between the local copy and the master. You've probably been places where you've seen maybe once a day updates. You can do everything in the local system, but suddenly at 4 o'clock in the afternoon, the big master database is updated. It's kind of similar to batch processing, but reality is the processing is actually being done at each local database or within each replica, and then at times the replica and the master exchange information. So it's during that exchange of information that your transactions are applied to the master database. But this is crucial, and of course, with as communication and cloud services and things become stronger and stronger, um, data replication and these types of big exchanges throughout the day aren't seen as much, but we still have databases, things, government databases, Visa and MasterCard. I mean, databases that are absolutely huge, and it doesn't matter how good the security and cloud, etc., gets, there's still going to be some type of data replication going on somewhere in the world. And finally, the last function that they discuss is utility services. They just briefly give you a list of some of these general maintenance services. A DBMS has to be able to have structural changes like creating new tables, changing field names, table names, importing and exporting data. Very crucial that your DBMS can do that. Supportive procedural languages like C++ or C Sharp, and as well as non-procedural languages such as SQL is a non-procedural language. An ability to create some type of a user interface, an ability to create or interact with some type of a report writer. These are all just overall utility services that need to be provided by your DBMS. So this chapter does a good job of discussing the 9 services, and I hope that this lecture was helpful. Thanks.